Next, we will see the double angle and the half angle formulas. So let us start with the double angle formulas. As the name implies, these are formulas for twice a certain angle. So for example, sine of 2 times theta equals 2 times the sine of theta times cosine of theta. Cosine of 2 times theta is cosine squared of theta minus sine squared of theta, or it is 1 minus 2 times the sine squared of the theta, or is 2 times cosine squared of theta minus 1. And then finally, tangent of 2 theta is 2 tangent theta divided by 1 minus tangent theta squared. The proofs of them are very easy. They follow immediately from the previous formula, so they follow immediately from the sum formulas. So proof. Let's start with sine 2 theta. Sine 2 theta is just sine of theta plus theta, which we saw was sine theta cosine theta plus cosine theta sine theta, or it is 2 times sine theta cosine theta. A similar reasoning holds for cosine of 2 theta. So this one is cosine theta plus theta, which is cosine theta minus sine theta times sine theta. So it is cosine squared of theta minus sine squared of theta. To obtain the other two formulas, the thing that we will be using is just a basic formula. Sine squared of theta plus cosine squared of theta is 1. So if we want to do one of them, so we say we change cosine squared of theta. Cosine squared is 1 minus sine squared, so it is 1 minus sine squared of theta minus the other sine squared of theta. So it's 1 minus 2 times sine squared of theta. We could also, instead of changing cosine, we could change the sine squared. If we do it with this, we get cosine squared of theta minus, and then sine squared of theta is 1 minus cosine squared of theta. So this is 2 times cosine squared of theta minus 1. And then the last one, the tangent of 2 theta. Tangent of 2 theta, again, is tangent theta plus theta. We plug in the formula, so this is tangent of theta plus the tangent of theta divided by 1 minus tangent of theta times tangent of theta, which is 2 times tangent theta divided by 1 minus tangent theta squared. So we have proven all three formulas very easily. They just follow from the addition formulas. Let us then take a look at the following example. So for example, we want to prove that sine 3x divided by sine x cosine x equals 4 times the cosine of x minus secant of x. To prove this, we will start from the left-hand side. So the left-hand side, sine 3x, we can write as sine of 2x plus x divided by sine x times cosine x. First step, we use the addition formula. So this one is sine 2x cosine x plus cosine 2x sine x divided by sine x cosine x. In the next step, we will use the double angle formula. So sine 2x is 2 times sine x cosine x, but with the cosine x which was already there, this becomes cosine squared x. And then for cosine 2x, we will use the formula 2 cosine squared of x minus 1 times sine of x divided by sine x cosine x. We immediately see that here we can delete the sine x. And so what we have here is 2 cosine squared of x plus 2 cosine squared of x minus 1. And then divided still by cosine of x. So this gives me 4 cosine x minus 1 divided by a cosine is a secant of x, which is what we were looking for. The following set of formulas are the half-angle formulas. So the formulas in this case are sine squared of alpha equal 1 minus cosine 2 alpha divided by 2. Cosine squared of alpha is 1 plus cosine 2 alpha divided by 2. And tangent squared of alpha equals 1 minus cosine 2 alpha divided by 1 plus cosine 2 alpha. So you might now wonder, why do we call them half-angle formulas? Because the original formulation was not with alpha, but was with alpha over 2. So originally the formula was sine squared alpha divided by 2 is 1 minus cosine of alpha divided by 2. And then you see easily, if I set alpha over 2 equal to beta, I get my original formula. So then I get sine of beta is 1 minus the cosine of alpha. Alpha is 2 beta. So it's 1 minus cosine 2 beta divided by 2, which corresponds to this formula. We can then prove these formulas. They are very simple. So the proof, we see that cosine 2 alpha is a constant in all of the formulas. So we'll just be using the formula for cosine 2 alpha. So cosine 2 alpha was 1 minus 2 times sine squared of alpha. And if we rework this one, we get that sine squared of alpha is 1 minus cosine 2 alpha divided by 2, giving the first formula. We also know that cosine of 2 alpha is 2 times cosine squared of alpha minus 1. Just rewrite this. So put the cosine squared on one side. So cosine squared of alpha is then 1 plus cosine 2 alpha divided by 2. And then finally the tangent. So tangent squared of alpha, we will just say this is sine squared of alpha divided by cosine squared of alpha. We know sine is 1 minus cosine 2 alpha divided by 2. We divide that by cosine squared. Cosine squared was 1 plus cosine 2 alpha divided by 2. Or we are left with 1 minus the cosine of 2 alpha divided 1 plus cosine of 2 alpha, which completes the proof. Where do we use this kind of formulas? Well, we use them in order to reduce the powers. So for example, we have a certain expression, in this case the expression of cosine squared x times sine squared of x, and we want to write this in terms of the first power of cosine. So we only want first degrees of cosine functions in it. How do we do it? Well, we just take the formula, we plug it in. So this one was cosine squared x sine squared of x. We know that cosine squared is 1 plus cosine 2 alpha divided by 2. This is 1 minus cosine 2 alpha divided by 2. We go to the next step. So this then becomes 1 minus cosine squared of 2 alpha divided by 4. So we have a minus b times a plus b is a squared minus b squared. And now we do the same thing again. We have a new cosine squared. So here this is 1 over 4 minus 1 over 4 cosine squared of 2x. And we apply the formula again. So it's 1 over 4 minus 1 over 4. Cosine squared was 1 plus cosine of 2 times the angle. So in this case the angle is 2x. So we get 4x divided by 2. Or finally we have 1 over 4 minus 1 over 8 minus 1 over 8 cosine 4 of x. This is 1 over 8 minus 1 over 8 cosine 4 of x. So when we look at the last formula, we see that we have expressed cosine squared x times sine squared of x as a formula with only cosine x, or only the first power of cosine, but it's no longer cosine x in this case, it has become cosine of 4x.